My name is Todd Gayley. I'm here to talk about Paclets and the new Wolfram Language Paclet repository. I'm going to show off the repository. I'll talk a little bit about Paclets in general, and then I will talk about how to use Paclets from the repository, and including some what I consider to be best practices for consuming Paclet code, and maybe some things that are not obvious. All right, so there's my outline, which I already explained. So I think we can say now that the Wolfram system has its own package manager, similar to those in other popular languages. Probably familiar with the pip tool and the PyPy repository in Python, things like npm and the npm registry for JavaScript, cargo and crates.io for Rust. Basically, most modern languages have some sort of package management system and an associated repository. And if you've used those things in those languages, you know how great those are, how important it is to the growth of the language to have a single repository where people contribute all sorts of things, a tool that's built into the system that knows how to get things from that repository. That is very important for the growth of a language, and we're very happy that we actually have this now for the Wolfram system. Very important aspect of the Wolfram language Paclet repository is that submissions are not curated. No human is going to look at your Paclet and approve it or not. Now, we do have some requirements that Paclets have to meet that they could cause them to be rejected, but a person is not going to look at it and say, no, I don't like what you've done here. You can't submit this. And another aspect of this is that when you submit something to the repository, it's basically made immediately available to the world. Right, so let's just go take a look at the repository. So here's the home page. We've got this little featured Paclets section. People might want to know how to get on the featured Paclets. I think it's mostly bribery. So there's a little alphabetical listing here. We have things organized into categories. There are some Paclets that are quite large. Here's this class-certain automata package. So this is what a Paclet home page looks like on the site. There's a line showing you how to install it, and then something that it looks familiar as like a guide page for the functionality of the Paclet. You can see that this Paclet has a very, very large, like a very, very, very large number of functions in it. There are others. Here's one. It only has 2 functions in it, right? Directory size, browser open. And they have, you'll have examples and things, and every one of these things goes to a function page. This is the git link Paclet. This is contributed by Wolfram. Now you'll notice that this is the name of the Paclet. It's Wolfram/gitlink. Paclets on the repository have stylized names where the first component is the publisher ID. Require that Paclets have names in this format. It's publisher ID / and then some sort of short name for the Paclet. And so this one, Wolfram/ things that Wolfram / are contributed by Wolfram. So there's some docs on how to use it. There's a bunch of function links to docs for individual functions, examples on this page. Then down at the bottom, there's some disclosures. It says local file. That means that this Paclet will read and write local files, right? And external services, it means it interacts with some external services. You might want to know if the Paclet you're downloading performs certain operations that maybe you're not comfortable with, or something you just want to know what it's doing. Just like when you install maybe an app on your iPhone, it tells you about some of the permissions it requires. There's a compatibility section that you can read, version history, maybe you have a license that you want to put in here, et cetera, et cetera. Maybe a see also section. So we'll look at this Paclet again. Later on, there's a search field. So if you want to know about Paclets that maybe mention probability in their text somewhere, they're searching. There's a document getting started using the Wolfram Language Paclet repository. I'm not going to go through this document much because it's basically the same thing I'm saying right now. Like, I can plagiarize it because I wrote it. And then here's another very useful document, creating Paclets for the Wolfram Language Paclet repository. All right, so there's just a brief little tour of the Paclet repository. So let's talk a little bit about Paclets in general, real quick. So they're just units of Wolfram functionality, and they're packaged in a way that allows them to be installed, discovered, updated, and importantly, integrated into the Wolfram environment. Right? And a lot of Paclets contain Wolfram language packages, probably most of them. But a packet can be a lot of different things. It can be as small as like a single documentation notebook. Could be a giant thing with many packages and its own documentation and front-end palettes, libraries, all sorts of things. Almost any resource that can be put into a Paclet. Paclets are heavily used within Wolfram research. In fact, there's around 370 Paclets in the Mathematica 13.2 layout. So the message here is that if you're creating any kind of content for Wolfram products that doesn't fit into one of our other repositories, like a single function for the function repository or a neural net for the neural net repository, if it doesn't fit in one of the existing repositories, then you should absolutely create it in the form of a Paclet and submit it to the WLPR. All right, so some general information more about Paclets. Paclets are versioned. The Packet Manager basically cares very much about the version. The Packet Manager is the component of the Wolfram engine that manages Paclets and weaves them into the system. And it cares very much about versions. It always wants to use the highest version number of any Paclet. But since Paclets are versioned, we can have side-by-side installation of multiple versions of a Paclet. Paclets have requirements. They can declare that they only work on a certain system ID. They only work with a certain version of the Wolfram engine or a certain range of versions of the Wolfram engine, or certain product names like Mathematica, or a Paclet can say, I only work with Math and Notebook Edition, that sort of thing. Paclets that don't match the current system are invisible in that session. They will not be seen or used. And most importantly, really, Paclets have extensions. Extensions are the way the Paclet tells the Packet Manager the things that the types of components that it has, the ways it extends the system. So a Paclet can say, I have some documentation. I have a package file that should be found by needs, et cetera, et cetera. All right, so the fundamental principle of the Packet Manager is that whenever the system goes to look up a Paclet by name or some resource that a Paclet might provide, the Packet Manager finds all the Paclets that could provide the resource. It culls out any ones that are either disabled by the user or don't match the current system. Then it takes the one from the Paclet with the highest version number. So that's a much smarter lookup than your standard kind of dollar path-based lookup, which is just a linear order of lookup. And you should know that when the kernel looks up a file or almost any other kind of resource, the Packet Manager gets the first crack at finding this. So something like dollar path is not even consulted, is only consulted if the Packet Manager cannot find a file. All right, so it is the presence of a PacletInfo file that makes something a Paclet, right? You take a file sitting there on your disk, you put a PacletInfo file next to it, you got a Paclet. A PacletInfo file is just a simple file of metadata in Wolfram language format that describes the Paclet, its requirements, and the ways that it extends the Wolfram environment. PacletInfo file is not code. You can't put arbitrary program into a PacletInfo file. You can't even put 2 + 2 into a PacletInfo file. It's like a metadata file. Even though it's in Wolfram language format, you shouldn't put sort of evaluatable code inside of a PacletInfo file. All right, so here I'll just glance at a non-trivial but not particularly complicated PacletInfo file. We've got this head Packet object, and then an association with some rules. The name and version are required. You can't have a Paclet that doesn't have a name and a version. You can have some short description. And then the extensions part is really the key. This is where you describe the things that your Paclet has. So this Paclet says, I have some extensions that the kernel should know about. And the root is a directory, the name of the directory in which these files will reside, a subdirectory of the Paclet. And this thing says, okay, context is file utilities. So when someone types needs file utilities, Paclet Manager says, oh, I know the Paclet that has that. It's this one, and it knows how to find the file. And you have a documentation extension. And as you can see, oftentimes these extensions are very short because your Paclet Manager has conventions about where things would be. So if you say, if you just say documentation extension as like a one-line thing, then if you have your documentation in the standard location, which is a documentation subdirectory, then the Paclet Manager will be able to weave that into the documentation of the system. Same thing with front end. And I'm not going to talk about some of these, what these extensions actually do, but this is what a PacletInfo file looks like. All right, so the Paclet system is documented. There's a guide page for Paclets. Here, I'll zoom this. Now there's function pages for all these are all Paclet Manager functions that operate on Paclets in the system. There's also some, links to the Paclet tools documentation, which is another Paclet that has a set of tools for building Paclets that are really of interest to Paclet developers. There's also a couple tutorial type documents about Paclets. This long Paclets overview thing is kind of where you go for detailed information about Paclets and the structure of Paclets. Then there's documentation on the Paclet repository site. I showed you these 2 pages a minute ago. They're more oriented towards the Paclet repository itself. Then there's some information docs for Paclet tools and the documentation tools palette. So this stuff is all documented. The Paclet Manager wasn't documented for years. I think people got into the assumption that there wasn't any documentation about the Paclet Manager, but there actually is now. So using Paclets from the Wolfram Language Paclet repository. So installing and loading. Okay, this page intentionally left blank. So I'll go to the Paclet repository. I'm going to use GitLink as a sample Paclet. So GitLink has this lovely little gray box. Paclets will have these things with this little link. It's click to copy for how to install it. So I've done that. I'll go here. Paste it in. All right, Paclet install GitLink. Now, that executed pretty quickly, but it did have to download. I don't have Wolfram GitLink installed, so it had to download it. And I get this Paclet object back. I can open this up, and I'll see that this location is down somewhere in my library Mathematica Paclets repository directory. All right, so if I want to use this thing, I'll go back to the browser. I'll do a click to copy on that. Paste that in. Now you notice that Paclets that have a context, the context is trivially derived from the name of the Paclet. So the Paclet is Wolfram/GitLink, and the context should be Wolfram backtick link backtick. And you can count on that. I just did a click to copy to get this thing. All right, so I've now loaded. So this is it, Paclet install, right? That's pretty easy. And then if it has code, you do have to call needs on the thing. So let's just, prove this works. Say I'm gonna set a directory, and then I'll call a function from the Paclet git clone, right? That is cloning. This is the LSP server repo. Maybe you've heard about LSP server. I just chose this. This code is actually, code for LSP server is actually all on GitHub. Tiny little summary box that came out, just doesn't zoom properly in the presentation notebook. All right, anyway, finding Paclet. So Paclet find remote is the function that looks for known Paclets with a certain name or other properties on any known Paclet servers. And now Paclet find remote works and Paclet install works because the Paclet Manager, because Mathematica knows about the Wolfram Language Paclet repository by default. So I can say, okay, Paclet find remote is like, I know there's a Paclet that has Mockingbird in its name, so I can do something like this with a string pattern, and I find this Paclet object. If I open this up and see the location of this Paclet is on the Wolfram Paclet repository site. All right, so Paclet find remote lets you sort of in a programmatic way find Paclets. Then you can also, because the Paclet system is integrated with the resource system, you can also use resource search to find Paclets. So this is going to find me all Paclets that are available out in the world that the resource system knows about that start with Wolfram / that have a publisher ID of Wolfram. And this returns it in a sort of a readable data set form. All right, so that's searching. And then of course, if I want to uninstall a Paclet, it's just Paclet uninstall. And now it's gone. All right. So we've all seen, so now we're going to talk about what I think are sort of good practices for using Paclets. The shadowing problem, we've all seen the shadowing messages that come up when you get two symbols that are from different contexts that are both visible, the same name, that are visible at the same time. We actually expect this to become a much bigger problem as the Paclet repository grows. I don't know, in that automata Paclet, for example, I'm sure you didn't notice in that huge long list, but there's a symbol called pairs. There's a symbol called words. I mean, there's going to be some conflicts with Paclet, symbols in Paclets, right? People are it's just a zoo out there. It's a free for all in terms of how you want to name your functions in your Paclets. So there are various techniques for handling this. One is context aliasing, which was a new feature in Mathematica 13, which I think people should, I talk about quite a bit. I think people should understand it. If I'm defining some function with a long context name, and then I can, in this line, will assign a context alias of CC backtick, basically is a short form for that long context. So then I can call CC backtick square of 5. Now, the real value of context aliasing comes along with this new syntax for needs. So if I want to load if I want to load the developer context, if I do it in this way, it acts just like needs, but it does two important things. One, it establishes this context alias of dev for the longer developer, but really importantly, it does not put developer on the context path. So now I can just call some function like this, and I don't have to. And if I that's wrong. I guess I'm not going to type it out. Developer is not on the context path. So this is a way of loading a package, making its symbols available with a short alias to this context, but not having all the symbols to the global namespace, the sort of soup of visible symbols. So this is what it looks like for a Paclet from the Paclet repository. I've got this Paclet that is, Wolfram code equivalence utilities, install it. And if I call needs in this form, I can now use this short alias for when I'm calling functions from this Paclet. And I have absolutely no idea why I got those messages, but it does say true. And you can see if I can check that Wolfram code equivalence utilities is not on the context path. So the point is that, okay, if you just want to let every Paclet that you call needs on, dump all the symbols into your global namespace, go ahead, it's fine. But as we get more and more Paclets and people start to depend more and more on coding Paclets, I think that you should get used to using this type of syntax where you don't load things where all the symbols become visible, but rather load them in such a way that you can use them with a very short context alias. So I do think, I think that people should get used to writing this type of needs statement instead of just needs. So PacletSymbol is a new function in 13 that lets you invoke functions from Paclets in a very convenient way. So here what I'm doing is I'm calling this function quantum basis from the symbol from the Paclet Wolfram quantum framework. And I don't have this Paclet installed. But if I just run this one line, it will go and install the Paclet and run the function. So this lets me, this single Paclet symbol call lets me call this function without doing anything at all other than just executing that one line. So PacletSymbol, it finds the Paclet, it finds the name Paclet or resource and installs it in a special way. It loads the Paclet's main context, but does not add the context to context path. And then it evaluates to the actual name of the symbol. So PacletSymbol does a couple things for you. It finds and installs the Paclet if necessary. If the Paclet's already installed, it doesn't have to do that. And it also loads the context, the Paclet's main context, but does not put it on context path. And how it installs the Paclet, it installs in such a way that it's made visible in the current session, but it was not visible in sub-sessions. Now, Paclet does not need to be downloaded again. If you invoke PacletSymbol in a future session, then the Paclet was instantly loaded and used again. It's not expensive to do that. But it's kind of like, we can sort of imagine this as like a try before you buy type of thing. I can just go to I can call PacletSymbol to invoke some function from the Paclet and see and have it run in my system. And if I don't care about that Paclet, I can just ignore it and the Paclet will not be present the next time I start the kernel. And one more, all right, so actually I should mention that on the Paclet repository, you'll notice in some of these examples, there's this little summary blob here. This is PacletSymbol, right? So I have clicked to copy, right? So if I click to copy this, you could think of PacletSymbol as being a really handy thing for doing click to copy. I get this blob, which if I hover over, you can see is really just evaluates the PacletSymbol. It's just a representation of the PacletSymbol function. So that's what it lets us do click to copy from the Paclet repository. See an example you like, click to copy, paste it into your session. It's just a call to PacletSymbol. And so that will download the Paclet if necessary and use it, but not clutter your future life with a full install of that Paclet. Okay, and then finally, just some things that people might not appreciate. Let's say I'm going to use a code from the Paclet in my own package, I'm going to give this to somebody else. So I have to put Paclet install somewhere in my code because I want to make sure that people who are using my code's not going to work if this other Paclet is not present on their system. But if I just call Paclet install on Wolfram Git link, what Paclet install does is it will install it if it's not present, but if it is present, it will also install an update if an update is available. And it's really probably bad form to have a side effect like that on your user systems, right? I don't want to give someone code that's going to cause them to get a newer version of a Paclet that they've already got. And so if you use allow version update false in Paclet install, that will get the Paclet if the user doesn't have it, but if they have any version of it, it will just use that version. So I think that people should get used to putting code like this in their packages. If you need to call Paclet install, use allow version update so you don't cause a side effect on user systems or your own user systems. And finally, another way to do this, I think a very slick way to do the same thing, is to use PacletSymbol. And I think so. If I want to use a handful of functions from Wolfram Git link in my own package, I can put PacletSymbol calls in my package, in the private section of my package. So I define my own functions, git clone and git pull, that just map to those symbols. And that's all I need to write. When that code runs, when this package loads on a user system, it will install the Paclet if necessary, but not put the symbols in the user's context path. And it will not cause an update. PacletSymbol will not do the update thing. So I think we kind of have a nice structure here where you have the section of your code where you're essentially importing the functions that you want to use from Paclets, and you're doing it in a very simple way and in such a way that it does not cause the Paclet to be updated on the user system. I'll say thank you very much.